So technically we're on day 3 of simplifying square roots. And yesterday we also learned about imaginary numbers and complex numbers. So we should be able to do the square root of x to the 18th, right? Just remember the square root is the power of 1/2. So what's the answer there? X to the 9. Okay, now what if you had the square root of x to the 19th? Well, you would have to rewrite 19 as x to the 18 times 1 more x, and then you could split the root, and then you could actually do the square root of x to the 18th, which would be x to the 9th, and the square root of x would stay. That's just a little review of simplifying square roots. We're good with that, right? Okay. And then yesterday we focused in on the variable I, which comes from the square root of a negative number, right? So the square root of -1 is I. And with that, you could conclude that I squared is really -1. And we could also conclude that I to the third is really I squared times 1 more I, which would be a -1 times I, which would be a negative I. And then the I to the fourth is really a I squared times I squared, which is really a -1 times -1, which is a +1. We did this yesterday. And you really want to memorize this guy and this guy, okay? Especially I to the fourth, because anything to the fourth power, I to the fourth power equals 1, which means anything that's divisible by 4, like if I said I to the 8th, well, that's really I to the fourth times I to the fourth, which is 1 times 1, which is 1. Anything divisible by 4, like I to the 12th, that's going to equal 1. Like I to the 20th, that's going to equal 1. Make sense? If I went I to the 21, then you got to think of it, well, 21, how many times does 4 go into 21? 4 times 5 is 21. But you need how many more i's to get to 21? You need 1 more I. So that means that the answer is 1 more I, right? So if I said, what is I to the 43rd? Think about that. I to the 43rd. Well, we know that I to the 40 becomes 1, and you have 3 i's left over. And what is I to the third? It's -I. So that answer is just -I. Make sense? Okay, so we learned that yesterday. We also learned that you simplify expressions with I just the way you would simplify expressions with any variable like x. So if this was a 3x plus 2x, the answer would be 5x. In this case, 3i plus 2i is 5i. The only difference is that if you ever multiplied the 2 i's together and you get I squared, then you'd have to replace the I squared with the -1. Okay, we did that yesterday. And what else did we cover this week? We also covered that when you're doing a square root, or when you apply a square root when solving an equation, you have to put a plus or minus in front of your answer. And if you do take the square root of a negative number, well, you're going to pull out that minus sign and it's going to become I. And then you could worry about simplifying the square root of 75 without the negative. And you could do that on the calculator, or you could do it by hand and split it and get 5 square root of 3. So what we really have here is I times 5 times square root of 3. The best answer would be to rewrite it x equals plus or minus, put the 5 first, the I second, and the radical at the end. 5i square root of 3. Again, we did this yesterday. Where did we stop yesterday? We stopped after simplifying the terms of I. Let's do this one. I know we did it yesterday, but let's do it one more time. When we distribute 3 times 3, we get 9. 3 times -2, we get -6 with an I. Positive 2i times 3, that's a positive 6 with an I. Positive 2i times -2i, well, a positive 2 times a -2 is a -4. And I times I is I squared. So we distributed. Now we need to combine like terms. The middle terms eliminate. And that I squared becomes what? -1. I squared is -1. Yay? Okay, so I really have -4 times -1. That's a positive 4. What about the 9? Bring it down. 9 plus 4 is 13. So this nasty looking problem that had a complex number times a complex number, it ended up being a beautiful answer, 13. And just to let you know, this always happens. Whenever you have a binomial times itself, but that middle term changes, the middle terms are going to cancel out. And when you're dealing with i's, the i's disappear. This is called the conjugate of this, or this is called the conjugate of that. Let's get into today's lesson because we stopped there yesterday. The conjugate of a plus bi is a minus bi. Yesterday we said that a complex number was the real part and then the imaginary part. Any number plus whatever number that's I, that's a binomial, that's a complex number. And the conjugate of this guy is simply changing the plus to a minus, or the conjugate of this guy is changing the minus to a plus. It's that simple. So when I say, or when I ask you, number one, what is the conjugate of 3 minus 2i? You're going to say what? 3 plus 2i. Simple, right? If I say, what's the conjugate of number 2, 5 plus I? What's the conjugate, guys? 5 minus I. Yeah, all you're doing is changing a sign. If I say, what's the conjugate of negative 3 minus 7i? What's the conjugate? Negative 3 plus 7i. Super easy. How about the last one? The conjugate of negative 2 plus 6i? Negative 2 minus 6i. Super easy, right? There will be a question on the practice quiz that is just saying, write the conjugate. And you just change the middle sign and that's it, okay? I think there'll be one on the test too, or on the quiz. Down here, we need to understand what it says here, that you don't want an imaginary number in the denominators of fractions, okay? And in order to get rid of an imaginary term, especially if it's a binomial, you're going to have to multiply by its conjugate, okay? Or as the notes say, by its complex conjugate, right? So on number one, you don't want to leave an I in the denominator. So you're going to have to take that binomial and you're going to have to multiply by its conjugate. But what you do to the bottom, you do to the top. So you're going to multiply the top also by its conjugate. But what is the conjugate? 1 minus 2i. Great. So everybody please follow along in your worksheet. So we already know that when we multiply a binomial by its conjugate, you're going to get a beautiful answer. The i's are going to cancel out, the middle terms are going to cancel out, and the i's become I squares, which becomes a negative 1. You get a nice answer. Check it out. Let me show you. We're going to go 1 times 1, that's 1. 1 times negative 2i, that's negative 2i. And then you're going to distribute positive 2i times 1, that's a positive 2i. And positive 2i times negative 2i is a negative 4. I times I is I squared. The middle terms eliminate. That'll always happen when you multiply a binomial by its conjugate. And then on top of that, the I squared, we know it's really negative 1. So I really have a negative 4 times negative 1, that's a positive 4. And what about that 1 in the front? Just bring it down. So in your denominator, you actually have a 5. Yay? What about on top? Well, on top, let's write our fraction over here. The answer is going to be, you distribute 3 times 1, that's 3. 3 times negative 2i, that's negative 6i. And of course, that is over that 5 that we got in the denominator. And that's your answer. However, I'll accept this answer if it's like an open response test. However, some multiple choice questions like to take the denominator and split it so you could have the real part all by itself and the imaginary part all by itself. So what do I mean by split it? So imagine this. If I said, what is 10 plus 8 divided by 2? We all know the answer is what? 18 divided by 2? 9. But you could, if you wanted to, take this 2 and put it as a denominator on the 10 and on the 8, and then add. 10 divided by 2 is 5. 8 divided by 2 is 4. 5 plus 4 is still 9. So you could take the denominator and split it. And that's what we're going to do. Not because you have to, but because on a multiple choice test, you might not see this. On a multiple choice test, you may just see the answer 3/5 minus 6/5 with the I on the side of that second fraction. Either one's good. Are you with me? Okay, so again, you don't want to leave an I in the denominator. Let's take a look at number 2. Number 2, I don't want that I. So I'm going to multiply both top and bottom by what? 2 plus 4i. Exactly, the conjugate. That's exactly right. And you're going to do that to the top as well, 2 plus 4i. So on the bottom, we have a binomial and we need to multiply by its conjugate. We're going to do some math. We're going to distribute. The middle terms are going to cancel out, and then the i's are going to become I squared, which is going to become a -1. It's going to work out beautifully. Check it out. 2 times 2, 4. 2 times 4i, positive 8i. -4 times positive 2i, negative 8i. -4 times positive 4, actually, negative 4i times positive 4i is negative 16i squared. And like I mentioned earlier, the middle terms will always eliminate. They're exact opposites. The I squared becomes a -1. So you really have a negative 16 times -1. That becomes a positive 16. What about that 4? Bring it down. Your denominator is 20. No more i's, no more binomials. A simple, nice, beautiful answer. Up on top, 5 times 2, 10. 5 times 4i, 20i. 20i, or 10 plus 20i over 20. That is an acceptable answer. However, if it's multiple choice, they probably split it, and especially because you're able to reduce those fractions. 10 over 20 plus 20 over 20 with an I. Well, 10 over 20 reduces down to 1/2, plus 20 over 20, that cancels out. You end up with just one I. So technically, that was the nicest looking answer, 1/2 plus I. Let's move on. How do I get rid of that? I in the bottom. Multiply by what? The conjugate. What's the conjugate? That's right, -3 minus 2i. Now you're going to do the same thing to the top, -3 minus 2i. However, the top has a binomial. So it's going to be a little bit more challenging than the previous ones. The previous ones just had one term up here. So you just distributed it and you were good. Right here you have two terms, so you're going to have to do distributive property on both. Which one do you want to do, the top or the bottom first? Doesn't matter, we're going to do both. Top, okay, the top. So let me get some space up here. Up on top, when I go 1 times -3, I get a -3. When I go 1 times 2i, or -2i, I get a -2i. And then I distribute the positive 2i times -3. I'm going to get a -6i. And then positive 2i times -2i is a -4i squared. Now, this was not a binomial times its conjugate. This is why the middle terms do not cancel out. I actually could combine -2i minus 6 more i's. That's going to be a total of -8 i's. But I do have an I squared. I squared is really a -1. So I really have a -4 times -1, which is a positive 4. What about the 3 out here? Just bring it down, and you have a, not a 3, it's a -3. So you have these 3 terms, and out of these 3 terms, you could combine that real number, -3, and that real number 4 to give you the real answer, positive 1, and with the -8i second. You always want the real number first and the imaginary number second. And that is over, and let's figure out what's on the bottom by doing the math. -3 times -3 is positive 9. -3 times -2i is positive 6i. Positive 2i times -3, that's a -6i. Positive 2i times -2i is a -4i squared. The middle terms are exact opposites. They do eliminate. That's because we multiplied a binomial by its conjugate. And not only that, this I squared is really a -1. So you have -4 times -1, which is a positive 4. And that 9 just simply comes down. And 9 plus 4 is 13. So there's my answer. Another acceptable answer would be 1 over 13 minus 8 over 13 with an I right next to it. And now for the last one. That's only one term. There's no binomial. I mean, you could make it look like a binomial by putting the real number 0 in the front, right? But that's kind of pointless. Don't do that, okay? I mean, just pause right now. Don't write this down. But if you wanted to, you could put a 0, and you could multiply by the conjugate and say 0 plus 3i, and multiply 0 plus 3. But see, it's kind of a waste of time. It's kind of a waste of time because in reality, if you only have a single term right here, and that single term really is saying -3 times I, if I simply multiply it by one more I, what is I times I? I squared, and what is I squared? negative 1. So I'm able to get rid of a single I by multiplying by one more I. And of course, what I do to the bottom, I do to the top. But up on top, I do have a binomial, so I'm going to have to distribute that I on the top. So on the bottom, I have negative 3, and then I times I is I squared. That's on the bottom. And up on top, I have to distribute I times 3 is 3I. I times I is plus I squared. Now, once again, I squared is really a negative 1. So on the bottom, I really have negative 3 times negative 1, which is a positive 3. And up on top, I squared is a negative 1. So I really have 3I plus negative 1. But of course, you want to write your real part first, negative 1 first, and your imaginary part second. And this is the answer. However, in a multiple choice test, they may split that denominator to completely separate the real from the imaginary. And that will be negative 1 over 3 plus 3 over 3 with an I. And 3 over 3 is really just 1. So they could write it as negative 1/3 plus 1I, or just plus I. Sound good? Okay. That's it with regards to imaginary. We also need to review something that we should all know, which is exponents from Algebra 1. So on this paper, we have all the rules of exponents, and you actually have those rules up on the wall right there, rules 1 through 7. And let's just go over and review each of these rules. I mean, everything's described for you and examples right there for you, but number 1, rule 1, it's simple. Whenever you have the same base, you simply add the exponents. Ask me why. Because x squared is really x times x, and x to the third is really x times x times x, and you are multiplying. So you really have 1, 2, 3, 4, 5 x's. Bam, there's your answer, x to the 5th. That's what x to the 5th actually means. It means x times x times x times x times x. Mathematicians always look at something and they create shortcuts. That's why there's a rule that when you have the same base, you simply add those exponents, okay? Now, if you actually had a number out here in the front, you could actually multiply those numbers. So if you look over here, example 1, the 2 and the 3, those are actual numbers, not exponents. 2 times 3 is 6. And then x to the 4th times x to the 2nd, you add 4 plus 2 and you get 6, okay? You could only combine the terms with the same base. So right here, 3 times 2 is 6. And then this x squared times that x to the 5th, you could add those and get x to the 7th, which you have right there. And you could take the y to the 3rd, and there is no other y, so it would just be y to the 3rd. And then you could take the z to the 1 and z to the 7th, that would be z to the 8th. Anyways, rule 1 is pretty simple, straightforward. When you're multiplying two terms with the same base, simply add those exponents. Rule 2, when you have a power to a power, you multiply them. Ask me why. Because x squared on the inside to the 3rd power, that 3rd power is telling you to multiply x squared times itself 3 times. And each of those x squares is really x times x. And you are multiplying all those x's. How many are there? 1, 2, 3, 4, 5, 6. Obviously, mathematicians see the truth and come up with a shortcut. The shortcut is a power to a power you multiply. Answer is x to the 6th, right? 6 x's, x to the 6th. Rule 3 and 4, anything that has parentheses with an exponent on the outside, you need to distribute that outside exponent to each inside exponent. And remember that a power to a power you multiply. So right here, you're going to take this power of 3 and distribute it to the invisible power of 1. And you multiply, power to a power multiply. So when you say 1 times 3, you get 3. So you really have 2 to the 3rd. And then 3 on the 2, power to a power multiply. 2 times 3 is 6. 3 on the invisible 1 on the y, that's going to be y to the 3rd. 3 on the 5, power to a power multiply, z to the 15th. The only other thing you could do is actually work out 2 to the 3rd. 2 to the 3rd is not 6. 2 to the 3rd is 2 times 2 times 2, which gives us this 8 right here. So anytime you have parentheses with an exponent on the outside, distribute that outside exponent to each term on the inside. And that's true even if you have a fraction on the inside of the parentheses. That power of 2 is going to go on the 3. You're going to end up with 3 squared up there. The power of 2 is going to go on the 4. You're going to end up with x to the 8th because of power to power you multiply. And on the bottom, you're going to distribute right there, and it's going to be a y to the 6 because 2 times 3 is 6. And the only other thing you could do here is 3 squared, which is 9. Yay? Nay? Okay. Rule 5. And of course, there's more rules over here, right? Not more rules, more examples. And there's a description of the rule. Rule 5 is the easiest one. Anything to the power of 0 is equal to 1. X to the power of 0 equals 1. Y to the power of 0 equals 1. 5 to the power of 0 equals 1. You get it? 1,385 to the power of 0 equals 1. Yay? So what if I said, what's 2x to the power of 0? What does that equal? It equals 2. What? Are you just said, right? Okay, no, check it out. Bottom line is, you really have 2 times x to the power of 0. What do you do first? Multiply or exponents? You have to do exponents first. That's a correct order of operations. X to the 0, we said, is 1, and you have a 2 times 1, which is 2. So that's the only curveball I could throw at you on this situation. Make sense? With this rule, anything to the 0 power equals 1. So right here, 2x to the 0, x to the 0 is really 1. The 2 doesn't have the power of 0. Now, it'd be a different story if you had everything in parentheses, and everything in parentheses had the power of 0 on the outside, then the whole thing becomes 1. Parentheses, everything on the inside has a power of 0, becomes 1. The whole thing has a power of 0, becomes 1. Make sense? But right here, the 2 does not have a power of 0. That's just a regular number 2 times that, which is 1. 2 times 1 is 2. The last 2 rules. Rule 6 is the negative exponent rule. Anytime you have a negative exponent, you got to grab that power and move it to the other side. And it becomes positive. So you moved it, it's no longer up there. There's only a y to the 5th up there. There's only a y to the 5th up there. That x to the negative 3 comes down, it becomes x to the positive 3, and the z is still down there. There's your final answer. Anytime you have negative exponents, I like to circle them and draw an arrow, move them to the other side, and they'll become positive. Let's look at more examples over here. So this guy, number 1, what has a negative exponent? Only the x has a negative exponent. So only the x to the negative 3 is going to move down to the other side. Other side of what? Go ahead and put a fraction bar. And that x to the negative 3, when it moves down, it becomes x to the positive 3. And that 2 stays up there. So your answer is 2 on top over x to the 3rd. There it is, 2 on top over x to the 3rd. Now, on this one, the whole thing has a power of negative 3. So you could move that whole thing down and you have a positive 3, but you still have to distribute. So you could distribute that here, distribute that there. You'll have both of these, and both of those have to move down to the other side. This one comes down, this one comes down. Because there's nothing left up on top, you put a 1, and 2 to the positive 3 is 8, and x to the positive 3 is x to the positive 3. On the third example, the only thing that has a negative exponent is the y. Everything else stays. This goes up, it becomes positive. There's your answer. Final rule is the canceling rule. We all know that 3 over 3 is 1, 5 over 5 is 1, 7 over 7 is 1, x over x is 1. So when you have x to the 3rd over x to the 5th, what is x to the 3rd? X to the 3rd is really x times x times x. What is x to the 5th? It's x times x times x times x times x. Of course, cancel, cancel, cancel. What's left? 2 x's on the bottom, nothing on top. So that's why you put a 1 up on top and an x squared on the bottom. It would be ridiculous to draw this out every single time. So what we're going to do is just understand that you're pretty much subtracting. So if I said, imagine if you wanted to write this out, like if I said x to the 73 over x to the 75, that would be ridiculous writing 73 x's on top and 75 x's on the bottom. It's this simple. All 73 x's cancel with 73 of the 75, leaving you 2 left over. So my answer is 1 over x squared. Got it? Okay. And you have examples over here. On the examples, I do expand, but you're not supposed to expand. Just think about canceling. So number 1 right here, it's simple. It's as simple as this. I have 2 x's on the bottom. All 2 x's cancel with 2 of the 3, leaving me 1 left over. I have 2 y's on top, 5 y's on the bottom. All 2 y's cancel with 2 of the 5, leaving me 3 left over on the bottom. And then you worry about your fraction, the actual numbers. That's a fraction 2/8. You could reduce by 2. You'll have a 1 over 4. So your answer will be 1x to the 1. So that's just going to be an x up on top over 4y to the third. So it's x up on top over 4y to the third. Got it? Okay. This guy right here, cancel out the y's. The y on the bottom completely cancels with one of the y's up on top. You have one y left up on top. 1x on top cancels with one of the two on the bottom, leaving you 1 on the bottom. And then 4/12, you could reduce by 4. You'll have a 1 and a 3. So your final answer is going to be 1y to the 1. So you're just going to have a y on top. And on the bottom, 3x to the 1. It's just going to be a 3x. So y on top, 3x on the bottom. That's what we have. Y on top, 3x on the bottom. You don't have to show this work. Okay. So if you flip the paper over, we have practice on exponents. The first half is practice on exponents. The second half is just doing distributed property, combining like terms. And of course, you may have some powers in there. But it's pretty simple. Rule 1, what's the answer? B to the 7th, piece of cake. Number 2, what's the answer? C to the 9th. You simply add them, right? I'm not even going to write the answer. You guys could do that. This one's interesting. Rule 1 says that when you multiply with the same base, you have to add the exponent. So what's my answer so far? A to the -7. And then rule, I don't know what number it is, but the negative exponent rule says that whenever you have a negative exponent, you got to grab it, move it to the other side of your fraction. So if you do move it to the other side, there's going to be nothing left up on top, and the a to the 7th becomes positive on the bottom. Okay. We also have like the canceling, I don't know, 8, 9, or 10. Pick one. 10. 10. Okay, so I have an R up on top and an R on the bottom. That R cancels with that R. It's gone. No more R's. How many T's do I have on top? How many T's do I have on the bottom? Oh, 2 of these T's cancel. Let me do a different color. 2 of these T's cancel with 2 of the 4, leaving me 2 left over up on top. How many P's do I have on top and bottom? Oh, 1 P up on top cancels with 1 of the 3, leaving me 2 left over on the bottom. And then I have the fraction to deal with, which is -10 divided by -5. Negative divided by negative is positive. 10 divided by 5 is 2. So you're going to have a 2 left over up on top. So what's our answer? We have a 2 up on top, t to the 2nd, and that's it. And on the bottom, you have nothing. You have a p squared, and that's it. Yay? Okay. So technically, all you got to do is practice with this worksheet. The answers are on Google Classroom. There's a video explaining more of these on Google Classroom. What else? The test is going to be the day after tomorrow. So make sure you're ready.